start explaining the whole 100%, 99%? Or?
Explain
No,
it.
not necessary.
Please.
Okay, then. So, 1, 2, 3, go. We're not trying to cheat Mother Nature. That sound scared me. So, usually more than 90% of that material is just waste. I mean, it doesn't contain any information. So any technique that we can use to concentrate the heavy minerals, which are usually the ones that carry the mineralization, will help us get better results. We are enriching the sample on purpose, which is what we need to get good results from the lab. So normally people do the panning. And for the pan, by the way, I didn't explain the first time. If you're going to do panning normally, instead of the little cup, you have a bucket of 10 liters. And the rest is the same. So, but it is important to always have the same weight. Sorry, the same volume. Okay? So 10 liters, you're doing a normal pan, something like this, that you later find out how many cubic centimeters are here. So, and you need a balance. So you fill the material, you weight it, you got volume by weight, gives you the density of the rock. And even that may tell you immediately if there is something good or not, because the more dense the sample, the most important it is. Actually, there is another thing that I forgot to explain, so it's good that the camera turned on. Okay, where do you get the sample in the river? This is a mechanical anomaly, so you need to apply a little bit of physics. You need to sample in places where the water in the stream accelerates, but not too much, accelerates enough to wash the light fraction, or stops enough so the heavy fraction will fall. So good places and an obstruction in the river, like a falling tree, that is usually one of the best places. You pick it up before the water. I mean, the trunk is here, the water goes here, you get it from here. Okay, so that is one of the best. The second thing to know is that the river always do meanders, and from one side he erodes. There, for example, it's eroding there, and then it deposits on the opposite side. So you take the sample from here. This is a good sample. Within the area, try to find out where you see rocks like this. Okay. And I know this is a problem because all these rocks need to be thrown away, but here, in this piece here, is your best concentrate of heavy minerals in the whole size here. So you see, there, wherever you see rocks, that is where you're going to take the sample. You see over here, there is nothing. Okay, so those are the important things. So, okay, let's go back. So as I mentioned, this you do it in the field, but because we have this sample taken before, we will fill this up. You hit it like that, so it will hit it. So that is your sample. So the next thing, you weigh this, and you know how much it weighs. Then you usually take something a little bit bigger, longer at least. This is 2 square. So you take a sieve of number 4, which is about ½ an inch. Okay, so you can throw away all the big rocks. So there is the sieve, okay, the invisible sieve. And then we need to make sure that we're going to take a couple of spoons, that this sample is representative of the meter you sample in the wall. So we need to homogenize this extremely well and then do quarters. So this I really discovered like a couple of months ago. A very easy way to do the homogenization is just grab this thing and then you put it up. You need to put it up. You need to put it up. No, sorry. Go down. You need to do that so it will move. Okay. Okay. Now we do the same, but from this side. Be hard, be hard. It must rotate. It cannot slide. It needs to rotate. Okay? So you need to do like this. No, it's a brisk movement. Like that. Okay? Brisk movement. Brisk movement. Ah! You got it. You got it. Okay, perfect. So now that it's well homogenized, we just distribute it. Make a quarter. By the way, I'm doing something really bad. Okay. And you just throw away 2 parts, and this is your sample. Okay, so we're going to take the sample from here. So, for that, we take a condom. Actually, this is the box. Power play. This is the one that you're going to need. Because all the other one has some forms, strange forms, and smells and stuff like that. We don't need that. So you just fill the condom with water from the river. Come on. And as I said before, the best one if it doesn't have any oil on it. But if not, we work with what we have. So now that we have the condom with about half the weight water, we just add the spoons of material. I will let you do completely the full one from the side for yourself. Now remember, the tip, grab the tip.
I can't use this spoon anymore, I must pack it.
You can put more. Actually, it's amazing. It takes enough material. So, if you see, there is no sorting there. They are just like they. So, we grab the condom here, and when I'm gonna do this first movement, and then I'm gonna lift the tip, and we're gonna do a vertical movement. Practice safe geology. So 10 seconds, 15 seconds, really, you don't need too much. And when you finish, you will see that all the heavy fraction are concentrated right here. And all this is like material, clay, etc. So basically by 50% minimum, you have concentrated the sample with the thing that you need. Now, to get the sample, you just grab it from where you want to get. Sometimes you are interested in the really, really heavy ones, you just grab this, the little pit, okay? If not, but at this exploration now, grab all the whole thing, throw it away, and that is yours.